Welcome to the workshop Electrical Impedance Tomography with the Pulma Vista from Draeger. My name is Peter Somhorst. I work as a technical physician at the intensive care unit of the Erasmus Medical Center in Rotterdam, the Netherlands. With EIT we can measure the distribution of air within the lungs during mechanical ventilation or even during spontaneous breathing. EIT uses a belt with electrodes. For example, this extra large one. The belt is made of silicone, so it's quite stretchable, and on the back are 16 electrodes that contact the patient and measure impedance changes in the patient during ventilation. The belt comes with a cable like this. Each electrode is clicked onto one of these connectors, and then the belt is connected to the Pulma Vista via the trunk cable with these connectors. Here we have the EIT belt put around the chest of the patient. The C connector is put in the proper position. The reference electrode, coming from the 16th electrode, is put on the belly of the patient with an ECG electrode. You can put it either on the belly or the upper arm of the patient. The belt is connected via the connectors to the Pulma Vista. Today's patient is Mr. A. Mr. A contracted COVID a few weeks ago. He was hospitalized, quickly intubated and admitted to the intensive care unit. He was ventilated already for a few weeks in supine and prone position. Unfortunately, he has not recovered yet. In the meanwhile, he has cleared his COVID, so he's not infectious anymore. He has late-stage ARDS, possibly with fibrosis and multiple consolidations. If you have connected everything to the Pulma Vista, this is the startup screen you're presented with. We press the Start Standby button, and from here we can start the measurement. What is important, if you want to have the data of the patient saved on the name of the patient, you first have to put in the information of the patient. So I press New Patient, and then I go to System Setup, Data Recording, Patient Data. Here we can put in the name, age or date of birth, the patient ID, and a short comment about the patient for later reference. Also, you can choose whether you want to have a single recording of, for example, 10 minutes, or a continuous recording which is split into files of, in this case, 10 minutes, which you can choose how long that recording is going. From the startup screen, you can check the quality of the signal with the button Signal Check. Here we see whether the connection between the belt and the patient is okay. For all electrodes, you see the resistance between the electrode and the patient. In this case, all resistances are below the threshold, which is shown in red, including the reference electrode. If one of the electrodes would be disconnected or have worse connection, you would see it would spike and the electrode becomes red on the screen. Now we can start the measurement. We press Start and the device starts calibrating. While calibrating, the data you see are not actually valid, so you have to wait until calibration is done. Now the signal is calibrated and you can look at the data. If you ever want to recalibrate because of repositioning, you can go to Signal Check and restart the calibration from here. In this main screen, we get an overview of all the data. We see here the dynamic image of the ventilation, here the tidal image of the ventilation, and here the global impedance change of the entire lung. Below that, the lung is divided into 4 regions of interest. You can set which regions of interest you want to see with the button Set ROI, and you could choose either layers, which are 4 layers from ventral to dorsal, quadrants, which are the 4 lung quadrants, or free, where you can select your own region of interest. We will set it to layers. Now the waveform of ROI1 is the most ventral part of the lung, ROI2 and 3 are the central parts of the lung, while ROI4 is the dorsal part of the lung. Here we can see the respiratory rate and the percentage of ventilation going to each region of interest. If we were to connect the Pulmo Vista to an Evita ventilator, we would get information about the tidal volume as well. Unfortunately, we currently don't have an Evita ventilator available for the demonstration. From the main screen, we go to the screen with the full screen image. Here we see the tidal impedance change during the ventilation. Here you see what the colors mean. Black means there's no tidal impedance change. Blue means there is some tidal impedance change. And white means there's a lot of tidal impedance change. Tidal impedance change is correlated with ventilation, so we can see the white areas are more ventilated than the darker blue areas. The Pulmo Vista automatically filters out cardiac frequencies. You can set the frequency in the system setup display and you can choose your filter. We now have a cutoff frequency of 40 beats per minute. We can change the frequency to, for example, 70 beats per minute. We now see some artifacts which are actually caused by the heart. We don't want to see those, so we're going to reduce the filter again to 40 beats per minute. From this screen, we can perform multiple tasks, which make it easier for analysis later on. We can export a screenshot, we can mark an event, we can review data, or we can make a recording of what we are measuring right now. I'll start the recording and mark the event as being at PEEP 16. While the Pulmo Vista is recording, we increased PEEP to 20 centimeters of water. I'll mark the event and make sure that we noted that this is PEEP 20. Now we wait for at least 2 minutes to have the EIT stabilize before we start reducing PEEP in steps of 2 centimeters of water. The Pulmo Vista has multiple diagnostic screens. If you go to Views and click on the End Inspiratory Trend, you can look at the differences in tidal impedance change over time. Here we did some PEEP steps and we can compare the tidal impedance difference from one time point to another. For example, like this. Here we see the reference image and here we see the cursor image. These give the tidal impedance change for each breath. Here we see the difference between the reference and the cursor. And we see that there is a blue area that shows increased impedance difference in the cursor time point compared to the reference. Here we can see that in values as the percentage for each region of interest. If you were to connect the Pulmo Vista to an Evita ventilator from Draeger, you would also see the set PEEP, the dynamic compliance and the tidal volume as measured by the mechanical ventilator. We can also go to the delta EELI trend. The EELI is the end expiratory lung impedance, and it is said that it changes with end expiratory lung volume. So if we were to increase PEEP, the end expiratory lung impedance would change. Again, we can compare the reference to the cursor and see here how the end expiratory lung impedance changes with the PEEP step or over time. Lastly, we have the diagnostics screen. From here, we can start a PEEP trial analysis or a custom analysis of several time points during your measurement. Right now, there are 4 time points selected during this measurement. If we push PEEP trial analysis, the Pulmo Vista will analyze the data as if it were a PEEP trial, either incremental or decremental. Due to instability of the patient, Unfortunately, we were not able to analyze the data from this demo. We will therefore take a look at data from a patient we measured previously. Here we have a patient with COVID-19 and ARDS, in whom we performed a PEEP trial from a maximum PEEP of 28 to a minimum PEEP of 8 centimeters of water, in steps of 2 centimeters of water. In the top row you see the global impedance curve in white, as well as the set PEEP level in green, and the peak inspiratory pressure in pink. The pressure data was recorded from the Evita mechanical ventilator connected to the Pulmovista. In this row we see the tidal impedance image, or the maximum impedance change during one breath at each PEEP level. At high PEEP, most of the impedance change takes place in the dorsal parts of the lung. At medium to high PEEP, the tidal impedance variation shifts towards the ventral part of the lung. At the lowest PEEP, most ventilation is in the ventral part of the lung. The third row shows an estimation of the hyperinflation at high PEEP compared to the lowest PEEP level. At the lowest PEEP level, no hyperinflation is measured, but it could be present either way. In white, we see the amount of collapse compared to the highest PEEP level. At low PEEP levels, we see a lot of collapse of the dorsal areas of the lung. At the highest PEEP level, we see no measured collapse, but it doesn't mean there is no collapse present. In the fourth row, we see a graph of the amount of collapse in white or hyperinflation in orange at each PEEP level. In this patient, we would choose to set PEEP at either level E or F, so about 19 or 21 centimeters of water total PEEP. If you want to review data you recorded earlier, you can go to Data Review and load a file from the hard drive. Thank you for joining us in this workshop. If you have any questions or want to discuss anything, please contact us at the Erasmus Medical Center in Rotterdam. My email address is p.somhorst, somhorst, @erasmusmc.nl.